In the dark waters of the mid-Atlantic during the early 1940s, German U-boats prowled like invisible predators, sinking Allied ships faster than reinforcements could arrive. The Atlantic was a battlefield, but one critical gap remained, a stretch of ocean too far from land for planes to patrol effectively. This gap threatened the lifeline of Britain, cutting off supplies and leaving convoys exposed to ruthless attacks. The Allies had no solution, and the United States faced a dire dilemma. They needed a base, but nowhere along the vast Atlantic expanse was there a suitable location. Time was running out, and every lost ship brought the world closer to catastrophe. It was in this tense moment that a remarkable political maneuver would change everything. In September 1940, the United States struck the Destroyers for Bases Agreement with Britain. 50 aging destroyers exchanged hands, and in return, the U.S. received rights to establish bases across the Atlantic. Among the most intriguing opportunities, and the most challenging, was a tiny, unremarkable island, hilly and barren, barely large enough for a single building. The British had long dismissed it as useless, too small, too rocky, too inhospitable to defend. Yet to the Americans, this tiny island represented the only chance to close the mid-Atlantic gap. Military planners immediately understood the magnitude of the challenge. The island's hills left no room for conventional airstrips, and the surrounding waters were deep and unpredictable. Every option seemed impossible, and yet the alternative, leaving the Atlantic vulnerable, was unacceptable. As engineers and strategists debated, a bold idea emerged. If nature would not provide the land they needed, they would create it themselves. They would dredge, fill, and reshape the island until it could support the planes and men essential to stopping the U-boat menace. The story of this decision is as much about ingenuity as it is about courage. It was not just about moving dirt or laying concrete, it was about envisioning a completely new reality in the middle of the ocean. Planners imagined runways rising where only waves once existed, hangars and barracks filling what had been empty, and patrol planes roaring into skies that had been silent. Every step carried risk. Storms could undo months of labor, equipment could fail, and mistakes could be fatal. Yet, despite the uncertainty, the U.S. Navy committed to a project that would redefine the very geography of warfare. Even before the first shovel hit the water, the stakes were clear. This base was not just another military outpost. It would become a linchpin in the fight against one of the most dangerous naval threats in history. The mid-Atlantic gap, long considered a weakness beyond repair, would soon be confronted by human ingenuity, determination, and sheer audacity. Engineers and planners worked day and night, often battling tides and weather that seemed determined to sabotage their progress. They pored over surveys, calculated dredging patterns, and imagined how every ton of material would transform the island into a fortress. Every decision mattered: where to place the first piles of rock, how to divert the strongest currents, which equipment could survive relentless storms, and at the heart of it all stood a tiny, forgotten island that, through effort and vision, would become one of the most critical bases of the Second World War, a testament to what can be achieved when ingenuity meets necessity and when determination refuses to accept the impossible.
The tiny islands of Boaz and Tucker were anything but promising. To the casual observer, they were nothing more than barren, hilly rocks rising from the Atlantic, too small to host any meaningful military installation. Yet for the United States, these islands held the key to an audacious plan. Survey teams arrived and immediately confronted the harsh reality: cliffs and uneven terrain, no natural flatland for a runway, and surrounding waters that shifted with tides and storms. Every option seemed to present insurmountable obstacles. Engineers and military planners began to map out every inch, measuring elevations, soil composition, and tidal patterns. Every rock and wave was a potential problem, yet the necessity of closing the mid-Atlantic gap left them no choice but to press forward. The British, while supportive in principle, had little faith in the endeavor. They saw these islands as strategic curiosities at best, inhospitable and exposed, with little hope for success. Yet political agreements were signed and permission was granted. The Americans were tasked not only with constructing a base, but effectively reinventing the islands themselves. They would have to flatten hills, reclaim land from the sea, and design runways where nature refused to cooperate. Military engineers knew that failure was not an option. Every shipment of supplies and troops passing through the Atlantic relied on the success of this project. The challenge extended beyond geography. The logistics of moving men, equipment, and materials across thousands of miles of ocean were staggering. Cranes, dredges, and barges had to arrive on schedule, and every delay could compromise the operation. Storms threatened to wash away progress before it could take root. Yet, despite the danger, the engineers approached the task with a combination of precision and creativity. They envisioned a connected island where once there had been two separate landmasses, a continuous platform rising above the water, capable of supporting not only aircraft but the entire infrastructure needed for sustained operations. The human element was equally critical. Teams of Seabees and Navy engineers worked under exhausting conditions, battling heat, insects, and unpredictable tides. Every day brought a new challenge, from equipment failures to the constant threat of weather undoing hours of labor. The men relied on both training and improvisation, often creating solutions on the spot. When one dredge sank in shallow water, another had to be repurposed, and when a hill proved impossible to flatten with machinery, teams turned to sheer manpower. The combination of planning and adaptability became a hallmark of the project. Yet the work was not purely technical. Engineers and commanders had to coordinate closely with political authorities, British officials, and naval strategists, ensuring that every step met strategic requirements. Decisions about runway length, aircraft types, and defensive positions had to be made before a single shovel touched the sand. They were designing a fortress before the land existed, creating a military installation from imagination and necessity. The scale of the operation was staggering and the tension palpable. One wrong calculation could set the entire project back by months. By the end of the initial surveys and planning phase, the vision had become clear. The tiny islands, long dismissed as insignificant, were about to be transformed into a critical hub of Atlantic defense. Boaz and Tucker would no longer be separate barren landmasses. They would become a single engineered foundation for airstrips, hangars, and barracks. The challenge was immense, but the stakes could not have been higher. Every Allied ship at sea, every convoy crossing the Atlantic depended on this improbable project. And as the first crews prepared to begin dredging and construction, a remarkable truth emerged. The limits of geography were only as strong as the determination of those willing to reshape it. The moment the first Seabees set foot on Boaz and Tucker's islands, the scale of the challenge became immediately clear. These islands were not forgiving. Jagged rocks, steep hills, and unstable shorelines stretched in every direction. There was no flat land for airstrips, no natural harbors for unloading the massive equipment, and every inch of terrain threatened to slow progress. Yet the men who arrived were among the best trained in military engineering, known for their ingenuity and relentless determination. They quickly assessed the site and began turning impossible ideas into concrete plans. The first task was dredging. Millions of tons of sand, rock, and sediment had to be moved from the seabed to create a stable foundation for the runways. Giant dredges clawed at the ocean floor, lifting material in seemingly endless streams, while barges ferried it to the island. Engineers devised methods to compact the sand and rock, ensuring it could withstand the weight of heavy aircraft. Every wave and current worked against them, constantly reshaping the very foundation they were trying to build.
One miscalculation could sink a barge or collapse a partially filled section, and yet the crews worked tirelessly, often from dawn until dark, against wind, rain, and relentless heat. Flattening the hills was another monumental task. Explosives were carefully placed and detonated to reduce elevations, while massive earth-moving equipment redistributed the rubble. Every detonation had to be precise, as too much could damage adjacent areas, while too little would leave the land unsuitable for aircraft. The Seabees relied on both science and experience, constantly adjusting their approach based on the shifting terrain and the unforgiving Atlantic weather. When machinery failed, men dug by hand, moving tons of rock with sheer effort and determination. Simultaneously, the construction teams laid the infrastructure that would make the base functional. Roads were carved out, barracks erected, and hangars constructed, all while the land itself continued to take shape beneath them. Pipes and electrical systems were installed, often on reclaimed land that had only recently been raised from the water. The ingenuity on display was staggering. Temporary floating docks allowed supply barges to unload in rough waters, while specialized cranes and winches moved massive equipment across uneven ground. Every system had to be designed to withstand storms, saltwater corrosion, and the constant vibrations of construction. As the island slowly transformed, the first runways began to take shape. Engineers calculated the precise alignment, length, and grade required for PBY Catalina and PB4Y Liberator patrol bombers. The work was painstaking, with crews measuring, leveling, and compacting the fill material until it was stable enough to support the aircraft. Every test roll, every trial landing carried the weight of the project's success. If the runways failed, the base would be useless, and months of labor could be erased overnight. Despite these enormous challenges, progress was undeniable. The two separate islands were gradually becoming one, a continuous platform rising from the sea. Roads, airstrips, and buildings began to give the illusion that the base had existed there for years. The men worked not just with machines, but with ingenuity, often improvising solutions for problems that no engineer's manual could have anticipated. Storms battered the newly reclaimed land, equipment broke under strain, and the Atlantic seemed determined to reclaim its territory. Yet every obstacle was met with perseverance, and slowly the impossible became reality. By the time the final stages of dredging and leveling were completed, Boaz and Tucker's Islands had been transformed into a fortress capable of projecting power across the Atlantic. What was once water and rock now supported airstrips, hangars, barracks, and command centers. The Seabees had not just built a base, they had reshaped the geography of warfare itself. The mid-Atlantic gap, once thought impossible to defend, now faced a formidable human-made threat, and the islands that had seemed so insignificant had become central to the Allies' strategy. As the final stretches of runway were leveled and compacted, the first aircraft prepared to land on what had been nothing more than water and rocky islands months earlier. The transformation was astonishing. Boaz and Tucker's Islands, once dismissed as insignificant, had become a sprawling military installation capable of supporting the most advanced patrol bombers of the era. The U.S. Navy Seabees and engineers had turned impossible terrain into a fortress in the middle of the Atlantic, and now the real test began: operational readiness. The first PBY Catalinas rolled down the freshly laid runways, their wheels kicking up clouds of dust and sand. These amphibious patrol bombers, vital for anti-submarine operations, were the first of many aircraft that would patrol the mid-Atlantic gap, seeking out the relentless German U-boats that had been decimating Allied convoys. The arrival of these planes marked the start of a new era. For the first time, aircraft could reach previously unreachable areas of the Atlantic, closing the gap that had cost countless lives and ships. Every takeoff and landing was a demonstration of engineering triumph and human determination. Alongside the aircraft, the base's infrastructure came alive. Hangars, maintenance facilities, and barracks quickly filled with personnel. Mechanics and ground crews worked tirelessly, servicing engines, loading ordnance, and preparing aircraft for extended missions. Command centers coordinated patrol routes and relayed intelligence, ensuring that every sortie was precise and effective. Even the smallest details mattered. Fuel storage, supply lines, and communication networks had to function flawlessly, as any failure could leave the Atlantic exposed. The coordination between engineers, pilots, and support personnel became the heartbeat of the base. The operational impact was immediate. Convoys that had once been vulnerable to U-boat attacks now sailed under the protection of constant aerial surveillance. German submarines, once able to strike with impunity in the mid-Atlantic, suddenly faced patrols they could neither evade nor anticipate. Reports of U-boat sightings increased, and Allied naval forces were able to respond faster than ever. Each successful patrol boosted morale and proved that the monumental effort to create the base had been worthwhile. The islands, once seen as barren and insignificant, had become a linchpin in the struggle for control of the Atlantic. The human stories behind the base were as remarkable as the strategic victories. Seabees, pilots, and support crews lived under challenging conditions, often contending with harsh weather, long hours, and the ever-present threat of enemy action. They formed a tight-knit community, improvising solutions and adapting to the relentless demands of life on a remote military installation. Letters home spoke of exhaustion and danger, but also of pride in being part of something unprecedented, an engineering marvel that had tangible effects on the war. The base continued to expand, accommodating larger aircraft and supporting more missions as the war progressed. PB4Y Liberators joined the Catalinas, extending the range and effectiveness of anti-submarine patrols. Night operations became routine, and the once empty skies over the mid-Atlantic were now a domain dominated by Allied air power. Every mission flown from Boaz and Tucker's Islands reduced the threat to convoys and tightened the noose around German submarines. The islands had transformed from barren rocks into a fully operational fortress with a reach that extended hundreds of miles across the ocean. By the time the base reached full operational capacity, it had proven its strategic worth beyond any doubt. What had begun as a daring plan to reclaim land from the sea had evolved into a critical hub of anti-submarine warfare. The mid-Atlantic gap, once a symbol of vulnerability, now was a controlled and defended region. Every aircraft launched, every convoy protected, and every U-boat spotted or sunk was a testament to human ingenuity, determination, and the extraordinary vision that had turned two small rocky islands into a key pillar of the Allied victory in the Atlantic.
The story of Boaz and Tucker's Islands did not end with the final landing of patrol bombers or the last convoy protected from U-boat attack. Its legacy extended far beyond the immediate victories of the Second World War. The transformation of barren rocks into a fully operational base proved that engineering could reshape the very geography of warfare, and that human ingenuity could overcome obstacles once deemed insurmountable. The principles demonstrated here, planning, adaptation, and relentless problem-solving, would influence military logistics for decades to come. NAS Bermuda became more than just a base. It became a symbol of what was possible when necessity demanded innovation. Engineers and Seabees had taken an inhospitable stretch of land, isolated in the middle of the Atlantic, and turned it into a hub capable of supporting multiple aircraft squadrons, extensive maintenance operations, and fully staffed command centers.
The base demonstrated that with vision, determination, and technical skill, military planners could create strategic assets in places where none had previously existed. This lesson resonated in later conflicts, where bases were built in deserts, jungles, and other previously uninhabitable locations. Strategically, the base proved invaluable. The mid-Atlantic, long considered a deadly gap in Allied defenses, was now under constant surveillance. Convoys moved with greater confidence, and the U-boat threat, once nearly unstoppable, was systematically countered. The presence of NAS Bermuda forced German commanders to rethink their tactics, stretching their resources and limiting their operational effectiveness. Every mission flown from the man-made runways reinforced the notion that geography, no matter how challenging, could be altered to serve the needs of strategy and security. The human element of the project left an equally lasting impression. The Seabees, pilots, and support crews who labored tirelessly on the base embodied a combination of skill, endurance, and creativity that became legendary. They worked under punishing conditions, shifting sands, relentless storms, and the constant threat of enemy action, yet their commitment never wavered. The lessons they learned about improvisation, collaboration, and solving problems under pressure became a blueprint for future military engineering projects. Stories of their ingenuity, solving unexpected challenges on the fly, turning setbacks into solutions, were passed down to generations of engineers and military planners. NAS Bermuda also influenced post-war strategy and the design of military installations. Planners realized that remote locations could be transformed into effective operational hubs if approached with careful planning and the right resources. The base's construction underscored the importance of flexibility, adaptability, and forward thinking in military logistics, showing that even the most daunting obstacles could be overcome with vision and determination. It was a living example of how engineering and strategy could intersect to produce outcomes that once seemed impossible. In the end, the legacy of Boaz and Tucker's Islands is a story of vision, audacity, and resilience. Two small, rocky outcrops in the Atlantic became a cornerstone of Allied success, closing the mid-Atlantic gap and protecting countless lives and shipments. The base demonstrated that when faced with seemingly insurmountable challenges, human ingenuity could reshape not just the land, but the course of history itself. Today, the story of NAS Bermuda remains a testament to what can be achieved when imagination, skill, and courage meet necessity. It stands as a reminder that even in the most unforgiving environments, determination and innovation can create solutions that leave a lasting mark on the world.